السلام عليكم ورحمة الله. الصوت واضح؟
عليكم السلام ورحمة الله وبركاته. دكتور علي واضح.
AUX mode.
صباح الخير.
صباح النور.
أسعد الله صباحكم جميعا، كيف حالكم؟
الله يخليك دكتور علي، كل سنة وحضرتك طيب.
طيب إن شاء الله، كيف أموركم؟ إن شاء الله بخير؟
كله بخير الحمد لله.
دكتور أحمد ها؟
أحمد الدمرداش. الله يخليك يا دكتور علي، إحنا بس الزملاء داخلين أهوت، بيجهزوا وداخلين على طول.
إن شاء الله. حابين نلقي تحية الدكتور
شبير والدكتور مارك هنر.
لسه ما دخلوا صح؟
هم بيجهزوا وداخلين أهو.
إن شاء الله بإذن الله. أسعد الله صباحكم جميعا، وإن شاء الله أتمنى نجاح لهذه الفعالية.
بإذن الله يا دكتور، وشاكرين لوزارة الزراعة تعاونها واهتمامها بصحة الإنسان وصحة الحيوان كمان.
شكرا لكم. إن شاء الله إذن إن شاء الله بإذن الله على الساعة 10 إن شاء الله نبدأ من الكلام.
بإذن الله. بإذن الله. Dr. Shabir, can you present?
We are going to start, inshallah, in 2 minutes. Just Dr. Shabir, just to make sure that we have the presentation working here. Dr. Demirdash, can you hear me well?
Very well, Dr. Ahmed.
Dr. Demirdash, I will wait your signal to start, but I'm asking Dr. Shabir again if he can just start sharing his desktop in order just to see that everything goes smooth.
Dr. Shabir, you hear me?
Shabs. Yes, I think he can hear us now. Yes, perfect. We'll be waiting your signal, Dr. Demirdash.
Okay, Dr. Ahmed. We can begin now. بسم الله الرحمن الرحيم. بشكر معالي الدكتور علي الدويري وكل الإخوة في وزارة الزراعة على هذا اللقاء والتعاون المستمر مع شركة إيلانكو لخدمة صحة الإنسان وصحة الحيوان، لأن طبعا المواضيع المهمة ديت بتهم صحة الإنسان وصحة الإنسان كمان. وأنا هنا هترك المجال لزميلي الدكتور أحمد العوفي يقدم ضيوف ويدير اللقاء إن شاء الله. اتفضل دكتور أحمد.
شكرا دكتور دمرداش على الفرصة العظيمة دي. يعني it's an honor and privilege صراحة إن احنا نكون موجودين النهاردة مع السعودي authorities مع سعودي customers. It's big deal for us صراحة and something we appreciate in Elanco. فبشكر الدكتور الدمرداش على الفرصة العظيمة اللي أتاحها لنا النهاردة دي. إن شاء الله بإذن الله يكون سيشن مش مثقل على حضراتكم. أنا وزميلي الدكتور جمال فران. جمال هو one of our global marketing leaders. I'm the marketing poultry manager in MENA GSA. We'll do our best today to coordinate these talks إن شاء الله بإذن الله today. احنا معانا نقول subject matter experts in the field. فهنبتدي إن شاء الله بإذن الله النهارده with Dr. Shabir Semji. Shabir is a medical doctor. He's if we are talking about his title in Elanco, is our chief medical officer in Elanco, but he also has different titles of global regulatory and technical research fellow. Very massive experience. Dr. Shabir will start. Dr. Ahmed Demirdash will interfere somehow, giving the Arabic summary. Followed by Dr. Shabir will be Dr. Mark Henninger. Dr. Mark Henninger is our market access director. He's based in France. He's overseeing, or he has responsibility on France, as well as the TMEA region, to talk about MENA GSE, North Africa, Gulf area, and until Pakistan. So I'm not really going to say too much today, but it's really it's our honor and privilege to be with Saudi parties today. This is very important meeting. We will allow like questions and answer sessions inshallah bi'Iznillah by the end of this meeting. So to all of our partners and colleagues, you can drop your questions in the chat box, and we will make sure that we will ask inshallah all of the questions. So
دكتور أحمد, just one comment. بس الدكتور علي نطلب من عليك تفتتح اللقاء النهارده
طبعا.
وتقدم.
تفضل دكتور علي, تفضل فندم. دكتور علي, you are muted.
السلام عليكم ورحمة الله وبركاته، وأسعد الله صباحكم بكل خير. بداية أشكر لشركة إيلانكو تعاونها في إقامة هذه الفعالية التوعوية، والتي تأتي يعني بالتزامن مع الأسبوع العالمي للتوعية بمضادات الميكروبات، واللي إن شاء الله بإذن الله راح يكون في نهاية هذا الأسبوع ابتداء من 18 نوفمبر لمدة أسبوع. طبعا احنا جزء من الصحة الواحدة العالمية، وجهود قطاع صحة الحيوان سواء في القطاع الحكومي أو القطاع الخاص يجب أن تتكامل مع القطاعات الأخرى في قطاع صحة الإنسان وقطاع صحة البيئة لتحقيق الاستفادة المثلى والتكامل بين القطاعات المختلفة وفق نهج الصحة الواحدة. طبعا أشكر لشركة إيلانكو هذه المبادرة لإقامة هذه الفعالية. أيضا أشكر مقدما جميع السادة اللي راح يعني يثرون هذه الفعالية، دكتور مارك، دكتور شبير، وأيضا زملائنا دكتور أحمد ودكتور جمال. طبعا يعني يجب أن الجميع يقوم بدوره في نشر الوعي باستخدام الأمثلة لمضادات الميكروبات في جميع القطاعات كافة. طبعا المملكة العربية السعودية من الدول الرائدة في التصدي لظاهرة الجراثيم أو الميكروبات المقاومة للمضادات على مستوى الشرق الأوسط، وبتكامل مع القطاع الخاص كما هو الآن مع شركة إيلانكو، وأيضا مع قطاع الدواجن راح بإذن الله نسهم في حماية الصحة العامة بإذن الله، وأيضا تعزيز استدامة الإنتاج الحيواني وخاصة قطاع الدواجن. أنا ما أحب يعني أطيل، وخاصة يعني كثير ما شاء الله تبارك الحضور جيد لحضور هذه الفعالية والاستفادة من المحتوى القيم اللي راح يقدم فيها. أيضا يعني الشكر موصول إلى جميع المشاركين، وراح أكون إن شاء الله بإذن الله متابع لهذه الفعالية إلى آخرها، والإجابة على استفسارات إن وجدت. يعني أتمنى لكم بالتوفيق إن شاء الله.
شكرا جزيلا دكتور علي، وإن شاء الله الميتنج تكون up to the expectation. And just to save the time now for all participants, I would like to ask Dr. Shabir to start his presentation. And just a reminder, بذكر حضراتكم إن في الشات بوكس ممكن حضراتكم to drop any question، وإن شاء الله نخلي في وقت للأسئلة والإجابات عليها. Dr. Shabir, we are all yours.
Thank you very much, and assalamu alaikum, everyone. It's a pleasure to be able to give this presentation to you guys. I'm going to set the first part of the talk, which is based on the science of AMR, and then my colleague Dr. Mark Henninger will do the policy side. So the idea is to bridge policy and science so that there is a clear understanding how policies are driven. So I'm sure you've seen multiple times newspaper cuttings and articles like this, which talks about antibiotic resistance in the food chain, which potentially leads to those resistant bacteria or resistance genes going through the food chain and causing infections in humans, which are then not treatable. And so there's a lot of pressure on not using antibiotics in veterinary medicine. Just like medical doctors, veterinarians take an oath, and embedded in that oath, they say they'll do everything in their capability and capacity to ensure the health and welfare of their animals. This means if they need to use an antibiotic or an antimicrobial to ensure that their patients recover and stay healthy, then they will do so. So the debate then moves from not using an antibiotic in veterinary medicine to how do you use an antibiotic that gives you the best clinical outcome for the animal with least selective pressure to create resistance that can then go through the food chain and potentially compromise antibiotic use in humans. So these will be the topics that we will cover today: the bacteria that are of particular interest, antimicrobials and antibiotic resistance. We'll talk about the different types of resistant profiles, and then we'll start talking a little about antibiotic resistance monitoring and risk assessment that drives policy. So to start with, what bacteria are we talking about? It's not across the board all bacteria. So it's not bacteria like Pasteurella, for example, that could cause respiratory disease in poultry, or Mannheimia hemolytica that would cause a bovine respiratory disease. We are not concerned about the disease-causing bacteria in animals. The bacteria we are concerned about are only 4 bacteria. We're concerned about the 2 foodborne pathogens, which is Salmonella and Campylobacter. And then we use E. coli and Enterococcus as your indicator organisms. Now, the reason we've chosen E. coli and Enterococcus globally, so these organisms have been used for the last 26, 27 years in surveillance programs, is because both E. coli and Enterococcus are found in all living organisms. They are very easy to work with, so you don't need anaerobic conditions, special media or anything. Most importantly, they're extremely, extremely promiscuous. So your E. coli is the gram-negative representative organism, and your Enterococcus is the gram-positive representative organism. Any resistant genes that are likely to be found in gram-negative bacteria are going to be present in E. coli. Any resistant genes that are present in gram-positive bacteria are likely to be found in Enterococcus. So we use those 2 organisms as indicator organisms to show what resistant genes may be present in gram-negatives and what resistant genes may be present in gram-positives. I'll talk a little about Salmonella and Campylobacter. So in terms of Salmonella, and this is non-typhoidal Salmonella, not typhoid-causing Salmonella, but non-typhoidal. These are gram-negative pathogens, and it's important when we differentiate that it's gram-positive or gram-negative, because as we go through the resistance profiling, it becomes important to understand, because some drugs, some antibiotics only work on gram-positive, some only on gram-negatives. So this is a gram-positive organism. It does cause foodborne diseases, and it has a very high rate of morbidity. Okay, so we often see people with vomiting, diarrhea, 2-3 days off work, and then they're back to work. We do see some mortality, but mortality is generally in the very young or the very old or the immunocompromised. We do currently have antibiotics that will treat Salmonella. There's not many left, but the drugs of choice used to be cephalosporins and fluoroquinolones. Nowadays, fluoroquinolones are hardly used for Salmonella. Typically, if we do have a confirmed Salmonella case, we will go in with a cephalosporin. We do see multi-drug resistant Salmonella, and I'll talk about that a bit later on in the presentation. When we look at Campylobacter, there's 2 species of interest, Campylobacter coli and Campylobacter jejunii. Of these, Campylobacter coli probably causes 2-3% of foodborne infections. 95 to 97% of Campylobacter infections, in fact 97 to 98% probably, are all caused by Campylobacter jejunii. Coli rarely causes a foodborne infection. We predominantly see jejunii. Again, this is a gram-negative bacteria. Again, we see quite a bit of morbidity, some degree of mortality. Mortality is in the same age groups, the very young, the very old. We see a lot in the immunocompromised. And typically, what you will see is it's not the Campylobacter or the Salmonella that kills the patient. It's because they have other underlying factors that end up leading to the death in these patients. Again, drug of choice typically would be a fluoroquinolone. If we get diagnosed that it's a Campylobacter infection, we typically change treatment to a macrolide, and here you'd use something like azithromycin. We very, very rarely see multi-drug resistant, if at all, in Campylobacter. It's more prominent in Salmonella. And now, just to add to this, if you do see a foodborne infection, as a physician, we don't typically go in with an antibiotic. Our first route of treatment is make sure the patient's stabilized, the patient's hydrated, iron levels are fine, and so on. The reason you would not treat foodborne pathogen is unless you have confirmed it's a non-toxin producing bacteria, you could potentially make the condition of the patient worse. By administering an antibiotic, you'll kill the bacteria. If it's a toxin producer, they will release more toxins as the bacteria lyse, and that makes the patient's condition a lot worse. So unless you've got a confirmed non-toxin producer, it's very unusual for us to go in with an antibiotic as first course of treatment. So just to be clear, we're not concerned about all bacteria. We're only concerned about Salmonella, Campylobacter, and then E. coli, Enterococcus as indicator organisms. And that brings us on then to antibiotics and resistance. Firstly, I want to start off by giving a clear definition between antimicrobials and antibiotics. All antibiotics are antimicrobials, but not all antimicrobials are antibiotics. Okay, so this picture makes it a lot more clearer. Antimicrobials is an overall classification for any molecule that has activity against a microorganism. So antimicrobials have activity against bacteria, virus, antifungals, and parasites. Then we go one level down and we go into the actual molecules themselves. So you've got antiparasitics. These can include dewormers, antiprotozoals, and this is where ionophores come into. Anticoccidials are antiparasitics. Okay, they have activity against parasites. We then have antifungals, like fluconazole, for example. We have antivirals, and then we have antibacterials. Antibacterials are the same as antibiotics, and they specifically have activity against bacteria. So it's important that we have these clear definitions of antimicrobial and antibiotics, and these are important, especially when you hear Dr. Henninger talk about policy. So resistance, people keep saying that resistance is new. It's been created since we started using antibiotics, and that's not entirely true. This is a paper from 2011 where the authors were digging into the soil in Alaska, and they used carbon dating to date the soil, and they went as far back as 30,000 years. They then isolated bacteria from those soil samples, and they looked for resistance genes. And they found the same resistance genes from 30,000 years ago that we find today. So not only were the genes for tetracyclines, glycopeptides, aminoglycosides, penicillins, and so on, but the structure of those genes from bacteria 30,000 years ago are the same structures that we see today. Okay, so by using antibiotics, we haven't actually created resistance. Resistance has been there from the beginning. The only thing that's happened is by overusing antibiotics, and we can argue human, veterinary sector, agriculture, and so on, it doesn't matter. The point is that by overusing antibiotics, we have extended the existing pool of resistance. We've increased the rate at which it spreads, and we've increased the bacterial number that are becoming resistant. So we haven't created resistance, but we are propagating resistance at a much faster rate had it not been for human intervention of overuse of antibiotics. And that's something that kind of makes sense, right? And it's Darwinian principles. It's survival of the fittest. You put pressure on an organism, it's going to adapt. And the fact resistance has been around for thousands of years, if we think back to how Darwin found penicillin, okay, sorry, not Darwin, Alexander Fleming. Fleming was working in his lab. He had a petri dish with Staph aureus growing, and he'd left for a few days. The plate was contaminated with a mold. He came back and he saw no growth around the mold, right? Then that led to the discovery of penicillin. The mold was excreting penicillin into the environment. That's what you would expect naturally, okay? You've got limited space, you've got limited nutrients, and you've got thousands of different bacterial species competing for the same environment and the same nutrients. So bacteria, molds, parasites, they're all going to have some kind of defense mechanism. And one of the mechanisms is to produce toxins, and the toxins would be in the form of an antimicrobial. So these organisms secrete these antimicrobials to kill off the competition in the environment. Those competitive bacteria then need a defense mechanism to survive in that environment. So they develop resistant mechanisms. So it's something that we would have expected to happen in nature, and that's exactly what we see. So we haven't created resistance. It's been there for a long time. We've just helped propagate it. Now, there's two kinds of resistant mechanisms. We have intrinsic resistance and we have acquired resistance. So intrinsic resistance is where bacteria are naturally resistant to an antibiotic. A good example is E. coli and penicillin. So E. coli are naturally non-susceptible to penicillin. So where you see publications where people say, oh, we've got chicken and we isolated E. coli from the chicken and there was 100% resistance to penicillin, that's not news, because those E. coli haven't developed resistance. They were naturally adapted in that way, which is why this differentiation of gram-positive and gram-negative becomes important. Some antibiotics just don't work on gram-negatives. Some don't work on gram-positives. So intrinsic resistance, we need to be aware of, but it's something we shouldn't be concerned with unless it's from a treatment perspective. So if you've got a chicken with E. coli infection, you're not going to give it a penicillin, right? Because it's not going to work against it. The resistance we are concerned with is acquired resistance. So the bacteria has adapted to become resistant over time. And there's two ways of a bacteria becoming resistant. We have chromosomal mutations. So this is where the bacteria, the bacteria have genes that, or proteins that the antibiotic targets. So the bacteria mutates its DNA, so it develops a new protein structure. So it doesn't have to be a massive change. It can just be one amino acid change in the protein structure that is sufficient for the antibiotic to no longer bind to its target, and you get resistance development. This is a very stable way of creating resistance, because once, everything costs energy, everything costs money, nothing is for free. It takes energy for the bacteria to create that mutation in its DNA. Once you've taken away the antibiotic pressure, so once you've removed the antibiotic from that environment, unless that mutation has a negative impact on the bacterial growth or survivability, the bacteria is not going to expand more energy to reverse that mutation. So once a chromosome has a mutation, that mutation is there to stay for good. So acquiring resistance by chromosomal mutation is a very stable way to maintain mutation in the bacteria once it's there. However, it's a very slow way to spread resistance, because that mutation only goes from parent to offspring when the bacteria replicate. Okay? It does not move from bacteria to bacteria in the same environment. It's only from parent to offspring, as you can see in this picture. The second way to acquire a resistance is by acquiring external pieces of DNA. And they come in different forms: transposons, integrons, and plasmids. So here you've got a picture of the green is the chromosomal DNA, and then the blue is your plasmid, which is an external piece of DNA that a bacteria acquires. And the red part is a resistance gene. Now, this is an expensive way to keep resistance, because plasmids, integrons, transposons, they don't have their own maintenance system in terms of keeping them alive and surviving. They have a symbiotic relationship with the organism. So the organism gives them an environment, it gives them nutrients, it gives them the space to survive. In return, they confer a positive benefit onto the bacteria. If you were to remove an antibiotic, so you remove the selective pressure, there's always a chance that the bacteria will expel that resistance gene out, because it no longer needs to maintain that plasmid, because there's no need for it to have a resistant mechanism. While that plasmid or transposon integron is in the bacteria, it can not only spread from parent to offspring when the bacteria replicate, it can also move to new bacteria, to other bacteria in the environment. So if you have an E. coli, or that's a good example. Let's take E. coli. If you have an E. coli with a resistance gene here, and it's in the same environment as other E. coli, this plasmid will replicate, make a copy of itself and transfer to another E. coli. In some cases, plasmids can also cross species and cross genuses. So you could have an E. coli plasmid transfer into a Salmonella, or you can have an Enterococcus plasmid transfer into a Staph aureus. So that's genus transfer. You could get species transfer where you've got a plasmid in an Enterococcus faecium and it can transfer into an Enterococcus fecalis. So the whole area of transferability is a massive and complex area, but it's one way, it's a quicker way for bacteria to spread resistance, because it's not only vertically from parent to offspring, it can also go horizontally from one bacteria to another bacteria. It can cross species, it can cross bacterial genuses. So that leads on to, so we know what bacteria we should be worried about. We know what types, what antibiotics are now, and we know what resistance and how resistance spreads. People get hung up on the different types of resistant mechanisms to start with. We have something called cross-resistance, we have co-selection and co-resistance. These terms are important to understand because all of this leads to a risk assessment process. And if you don't understand these terms, then it becomes hard to do a risk assessment. And I'll go through each of these terms one by one. So when we talk about cross-resistance in the strictest sense means resistance to one antibiotic in a class leading to resistance to other antibiotics in the same class. So for example, if we take the tetracyclines, we have minocycline, doxycycline, tetracycline, and tigecycline, which is a new third generation tetracycline. You could have a resistant mechanism that only gives you resistance to tetracycline. You could have another mechanism that gives you resistance to tetracycline and minocycline, or to tetra, mino, and doxy. Or you could have a resistant mechanism giving you resistance to mino and doxy. So that's called cross-resistance, resistance to one antibiotic in a class, giving you resistance to other antibiotics in the same class. This gets very complicated when you have a lot of antibiotics in the same group. So for example, we currently have about 12 aminoglycosides on the market. Predominantly on the human side, there's only 1 or 2 used in vet med, but there's 12 aminoglycosides. We have over 65 different resistant mechanisms for the aminoglycosides. Some will only give you resistance to gentamicin, some give you cross-resistance to tobramycin, amikacin, streptomycin, spectinomycin, and so on. We have one particular mechanism, the AAC6', the APH2 double prime, that gives you resistance to all the aminoglycosides across the board, except for apomycin. So every clinically used aminoglycoside on the human side becomes resistant to that one particular mechanism of resistance. We then have co-selection. So right in the beginning, when I mentioned Salmonella, I said that we have a Salmonella that are multi-drug resistant. This is a typical Salmonella that we tend to find in Europe and in many parts of the world now. It's resistant to 5 different antibiotics. It's resistant to ampicillin, chloramphenicol, streptomycin, sulfamethoxazole, and tetracycline. Now, when we look at gene expression, we have the bacteria contains so many genes, and not every gene will be expressed all the time. If that was to happen, you'd have so much protein in the cell that the cell would just explode. You just don't have that much capacity in the cell to contain that volume of protein. So each gene has a start sequence and a stop sequence. So when the cell needs to express a gene, it will trigger a whole process, and you have enzymes that will start translating DNA into RNA, which is then coded into proteins. So let's say you've got chicken and you've started treating the chicken with tetracycline, as an example. What's going to happen is the bacteria is going to trigger enzymes to express the tetracycline resistance gene. However, for the gene to be coded, the enzyme needs to recognize a start sequence. And the start sequence happens to be at the start of a whole cassette that codes for resistance to all these other antibiotics. So when you use tetracycline, this salmonella is going to express resistance to all these other antibiotics as well as tetracycline before coding of that DNA to RNA stops. And this is called co-selection. It means multiple resistance genes all encased in one regulatory unit. And what happens is this is a very complex structure, and typically you will never lose genes. You'll actually acquire more genes over time. And it's not uncommon now to find this kind of structure with 7, 8, 9 different resistance genes. Once a gene has been captured into this cassette, we call this a cassette, it's next to impossible to lose that gene. So we typically find chloramphenicol resistance in Salmonella in Europe. It doesn't mean that we use chloramphenicol. We have not used chloramphenicol in Europe for over 20, 25 years, but we still see chloramphenicol resistance. And the reason is because that resistance gene has been captured in this cassette. So as long as we continue to use one of these other antibiotics, chloramphenicol resistance will always stay in Salmonella. So this is co-selection, where you have multiple resistance genes all within one operating system. We then have co-resistance. Co-resistance is multiple resistance genes again. So ampicillin, chloramphenicol, sulfur, streptomycin, tetracycline. I'm using this as an example. All on one piece of DNA, but this time, each single gene has its own operating system. So each has a start and stop, which means now, if you were to expose this animal that has this salmonella with this resistant phenotype, and you use tetracycline, the enzyme that's going to decode the tetracycline resistance gene will come along, look for the TET gene, then it will look for the start sequence. The start sequence is just before the TET gene. So it will only translate and express the tetracycline resistance. It will not give you resistance, express the resistance to all these other antibiotics. So that's the main difference between co-selection, multiple resistance genes, all in one cassette. Co-resistance, all the resistance genes on the same piece of DNA, but each is independent of each other. That leads us to what do we define as multi-drug resistance? And people get confused here a lot. They think multi-drug resistant means resistance to everything. That's not the case. We have 3 separate, distinct classifications of multi-drug resistant. We have multi-drug resistant, extensive drug resistant, and pan-drug resistant. Multi-drug resistant means resistance to 3 or more classes of antibiotics. So if we again take the tetracycline example, you have resistance to tetracycline, minocycline, doxycycline. That's resistance to 3 antibiotics, but it's resistance to 1 class, the tetracycline. So that is not multi-drug resistant. But if you have resistance to, let's say, tetracycline, penicillins, aminoglycosides, there you go, 3 classes, that's multi-drug resistant. Now, let's say you have a bacteria that is naturally susceptible to 10 classes of antibiotics. And that bacteria over time becomes more and more and more resistant. And you now have resistance to 8 or 9 antibiotic classes. That means susceptibility to 1 or 2 antibiotic classes only. That is called extensive drug resistant. Now, we see multi-drug resistant in humans and animals. We see extensive drug resistance predominantly in humans. We're slowly starting to see emerge in veterinary medicine. It's not that prominent, but it's slowly starting. We then have pan-drug resistance. Pan-drug resistant means your bacteria is resistant now to every antibiotic class that it should naturally be susceptible to. So not intrinsically resistant, but it's naturally susceptible. It's now become resistant to every one of those antibiotics. and that's called pan-drug resistant. We don't see pan-drug resistance in veterinary medicine, but we increasingly see pan-drug resistance on the human side, predominantly in HIV patients. So these patients have, and it's with TB, Mycobacterium tuberculosis, and it's becoming extremely difficult to treat these patients. So this is a summary in Arabic. I think someone on the call is going to go through this. Ahmed, are you going through?
اوكي شبير. الدكتور شبير اتكلم ككونكلوجن عن المقاومة البكتيرية للمضادات الحيوية، وهي ظاهرة طبيعية وقديمة جدا، يعني ليست وليدة الفترة الحالية، ولكن من 30,000 سنة كان في مقاومة للمضادات الحيوية. أنواع المقاومة البكتيرية في مقاومة الطبيعية، واللي بتكون فيها البكتيريا مقاومة في الأساس للمضادات الحيوية، وذكر الدكتور شبير أمثلة زي البنسلين والإيكولاي، والمقاومة المكتسبة والتي تكتسب فيها البكتيريا مقاومة للمضادات الحيوية عن طريق الطفرات الكروموسومية أو نتيجة انتقال الحمض النووي المتحرك من بكتيريا لبكتيريا أخرى. المقاومة المتعددة للمضادات الحيوية قد تكون جزئية وقد تمتد لتشمل كل أنواع المضادات الحيوية. أوكي دكتور شبير.
Okay, thank you. So next we will quickly talk about what steps are being taken to try and reduce antimicrobial resistance. As you know, several years ago, the WHO brought out the Global Action Plan on trying to contain antimicrobial resistance. Again, then other organizations brought out similar national action plans. There were guidelines put in place, but obviously these are advisory guidelines. They're not legally binding. And the whole idea was that the national or the global action plan be taken down at a national level, and every country and region develop their own national action plans. If we look at the national action plans from the countries, they all more or less say the same thing, right? We need to establish a harmonized resistance monitoring program, regulatory controls and measures, so policy should be based on risk assessment. We need formulation of national responsible use guidelines, and we need to have an established harmonized antibiotic usage monitoring program. Essentially, that's what national action plans are saying. There's nothing more or nothing less in those national action plans, and they're all aligned with the WHO's global action plan. Now, one of the things that we keep repeatedly say is that, yes, it's great, people are saying there's resistance out there, but if there's no evidence, if no one's monitoring it, how do you know resistance is there? And we've always consistently heard that, we get a lot of resistance coming from Asia, we get a lot of resistance coming from Asia. Well, if there's no data, there's no way to say if that's true or not. So this is some national surveillance programs that have been around for quite some time. I've given examples. So we've got DANMAP, which is the first surveillance program that came out. In fact, DANMAP celebrates 25 years this year. There's Moran from the Netherlands. We've got NAMS from the USA, and we've got SIPARS from Canada. These are just examples, but there's a lot of countries now do national surveillance programs. Going back to what I said about Asia, so there was this whole thing where there was a lot of pressure to say resistance comes from Asia, resistance comes from Asia. They did not have any data. I did a study with the FAO, the Food and Agricultural Organization. We looked at published reports from Asia on antibiotic resistance monitoring in cattle, swine, poultry, and it was really fascinating. This report came out in 2011 that for a number of antibiotics, resistance was actually higher in Europe and the USA than it was in Asia. Resistance in animals in Asia is not as high as people keep saying it is. Actually, you've got a lot more resistance on the human side than on the veterinary side across Asia. despite a lot of antibiotics being used in that region. So when you do surveillance programs, this is essentially what you end up with, right? MIC data. So it's broken down. This is just an example I've made. So it's broken down into host species. So for this example, it could be any drug. We've got cattle, swine, chicken. We've got the concentration of the drugs and the percentage of bacteria within that concentration. And then you break the data down into total numbers, MIC 50, MIC 90. If you have breakpoints, you can say, what's the percentage resistant? This is great. This is of academic interest. It's not going to tell you anything beyond, do you have resistance? Don't you have resistance? To make this data meaningful, you need to put it into a risk assessment. And the cornerstone of a risk assessment is antibiotic resistance monitoring. So you do antibiotic resistance monitoring, you do a risk assessment using that data. If your risk assessment tells you you've got a risk, you've got resistance that's going through the food chain, compromising human use, you then put policies in place. You manage the risk. You do risk management, risk communication. How do you know if the policies that you have put in place are working? You have to carry on doing resistance monitoring. If your resistance is coming down, you have the right policies. If your resistance is static or continues to increase, which we have seen, then you've got the wrong policies. And an example there would be the USA banned the use of enrofloxacin in poultry back in 2004. And this was because there was a big concern that enrofloxacin use was causing resistance in Campylobacter, which then compromised the use of ciprofloxacin to treat Campylobacter infections in humans. The FDA implemented the ban in 2003, giving a 1-year transition period. At that time, fluoroquinolone resistance in Campylobacter was about 22–23%. The ban came in 2004. By 2018, so 14 years after the ban, resistance in Campylobacter to fluoroquinolones in the US is around 36–38%. So 14 years post-ban, resistance hasn't decreased. Resistance has actually increased. And there's a number of reasons we can discuss about why that happened. And so that's why it's important that you carry on monitoring for resistance. It will give you a good idea if your policies are working or they're not working. So when we talk about risk assessment, it's actually very simple. Risk assessment has 3 components: release, exposure, consequence. Release means, are you using an antibiotic at the farm level? And are you causing resistance in 1 or all 4 of your bacteria of concern? So this is Campylobacter, Salmonella, E. coli, Enterococcus. If the answer is yes, you then look at the human-animal interface, the exposure part. And the exposure part means, are humans being exposed to those resistant bacteria? So your samples then, so your first step, samples come from the farm. Your second step, samples would come from slaughterhouses or from retail meat. If you still find bacteria, Salmonella, Campylobacter, E. coli, Enterococcus, that are resistant to the drug of interest, you then look at the consequence. Do you see human infections? Are those infections resistant to 1 or all 4 of those bacteria to the antibiotic class used at the farm level? And are you, most importantly, going to use that antibiotic to treat that infection in a human? So if we go back to our Salmonella was resistant to 5 antibiotics: ampicillin, amoxicillin, chloramphenicol, ampicillin, chloramphenicol, sulfamethoxazole, streptomycin, and tetracycline. That's worrying, right? You've got resistance to 5 antibiotics. But if you were to go through the risk assessment pathway, it's not of concern because you don't use any of those drugs to treat that Salmonella. If anything, you're going to use a cephalosporin. That Salmonella is totally susceptible to cephalosporin. So there's no human risk Yes, it's got resistance to 5 antibiotics, but you can still treat it if that salmonella caused a human infection. And that's what the consequence piece is. That's the most important part of a risk assessment. So I'll give you some examples. Let's take the Ionophores. Okay, these are non-medically important, and Mark will talk about this in a bit more detail, but this means these classes not used in human medicine. More importantly, Ionophores have been around for 40, 45 years. We do not see resistance in bacteria to Ionophores. So if there's no release, because there's no resistance, there's no exposure. If there's no exposure, there's no consequence. So when you do a risk assessment, you have a release part, yes, you have an exposure part, but at your consequence part, there's no risk assessment because this particular drug has no consequence because it's not used in human medicine. And more importantly, we don't see resistance in bacteria to Ionophores. If we take something like orthosomycins, so this is again a non-medically important antibiotic. It's not used in human medicine. Now here, 3 out of your 4 bacteria are intrinsically resistant. So avilamycin, which is an orthosomycin, has no activity against Campylobacter, Salmonella, E. coli. These 3 bacteria are intrinsically resistant. We talked about that before, naturally resistant. We don't care. The only bug we care about is Enterococcus. And yes, we do find at the release stage on the farm, a small proportion of Enterococcus resistant to avilamycin. When you look at the human animal exposure, yeah, you might see a small proportion which is still there. But if that Enterococcus went through the food chain, if that Enterococcus caused a human infection, there is no concern because you would not use this orthosomycin class in human medicine. So there's no consequence for cross-resistance. You would use a glycopeptide as an example, a lincosamide as an example. You might even use streptogrammin as an example to treat that Enterococcus. So you've got an array of other drugs which do not compromise the use of avilamycin in veterinary medicine. So again, it's a safe risk assessment profile. Yes, there's release, yes, there's exposure, but there is no human health consequence. A third example would be, let's take macrolides. Now, the macrolides I'm going to talk about are only have activity against Campylobacter and Enterococcus. So E. coli and Salmonella remain intrinsically resistant. We do see Campylobacter and Enterococcus at release and exposure that are resistant to macrolides. We see human infections of Campylobacter and Enterococcus which are resistant to macrolides, which means we now need to quantify how great a risk there is. And that's why we need a risk assessment for this particular molecule in detail. This was a risk assessment done in 2004 by Scott Hurd. We have the model and we put numbers in every 2-3 years. And surprisingly, the risk assessment number has not changed over the years. And I will show you the risk assessment and we will focus on poultry because that's where the greatest risk is. Swine cattle, there's really little risk. This is the risk assessment profile, the release part, the exposure part, and then we have the consequence part. And what this tells you, and this data is for the USA. So what this tells you is, do you have poultry that you treat with a macrolide? Does that cause resistance in Campylobacter or Enterococcus? Do those then go through the food chain and cause a human infection? Is the infection so bad that the human needs medical intervention and the physician prescribes a macrolide and the human fails treatment? So it doesn't mean the humans died. All it means is that they had Campylobacter infection, they had diarrhea, vomiting, ended up seeing a physician. Physician gives a macrolide. 18 hours, 24 hours after starting treatment, they are still vomiting. They go back and the physician will change treatment and give a different drug. So the patient doesn't die, but they get 1 extra day of diarrhea and or vomiting. For the USA, this number was calculated to be less than 1 in 14 million cases in Campylobacter. That means 22 cases per year. For Enterococcus, it's less than 1 in 3 billion cases, which means 1 case every 10 years. Now, when you do a risk assessment, you'll never get a zero number. Okay, everything has a risk. You know, you taking a shower, you could slip in the shower. Driving a car, you could have an accident. You probably won't, but you could. You cannot ever say there's a zero risk, something's not going to happen. And some people would argue that 22 cases per year of people having one extra day of diarrhea is still a risk. So just for fun, we put these numbers into real-time numbers for the USA. Being a victim of violent crime, 1 in 200 chances. Dying from cancer, 1 in 500 chances. Being struck by lightning, 1 in 500,000 chances. Dying from a bee sting, 1 in 6 million. All these factors will kill you. You've got twice as much chance in the US of dying from a bee sting than getting a Campylobacter infection from poultry that's resistant to macrolides and getting 1 extra day only of vomiting or diarrhea. Okay, so yes, we accept there's a risk, but the risk is very, very, very small. And it doesn't kill you. It gives you 1 extra day of diarrhea. All these other risk factors, which are much greater in the US, would all end up killing you. Because what a risk assessment tells you. So just to end, responsible use of antibiotics does not mean not using an antibiotic. It means using the right antibiotic. So you need to know about, most importantly, cross resistance, but using the right antibiotic by the right route, by the right amount for the right period. That's why our drugs have an SPC. There's a product label in there for users to follow. Yeah, those product labels are not created just randomly. There's a lot of work, effort, and science that goes behind it. If you carry on using a drug responsibly, you will reduce, if not eliminate, resistance development. With that, I'll turn it back over to Ahmed to do the summary, and then
Thanks شبير. الجزء اللي اتكلم عنه الدكتور شبير بيوضح أهمية إن يكون في قواعد إرشادية للاستخدام المسؤول للمضادات الحيوية. وهنا يجي دور الرصد للمقاومة البكتيرية للمضادات الحيوية على مستوى الإنسان وعلى مستوى الحيوان، وتقييم المخاطر الثلاثية للمضادات الحيوية سواء الريليز والإكسبوجر والكونسيكونس. المضادات الحيوية التي لا تستخدم في العلاج البشري لا تحتاج برنامج لتقييم المخاطر زي الأيونوفورز والأفيلاميسين على سبيل المثال. الاستخدام المسؤول للمضادات الحيوية لا يعني مجرد استخدام عدد أقل من المضادات الحيوية، ولكن استخدام المضاد الحيوي بالجرعة الصحيحة والطريقة الصحيحة، الروت المضبوط، والمدة الزمنية الصحيحة حتى لا يحدث مقاومة للمضادات الحيوية. أوكي دكتور شبير.
Before شكرا دكتور دمرداش. I just have here one question from Dr. Muhammad Al-Hutaymi. I think this is for you, Dr. Shabir, please. What do you think about the natural antibiotics products in minimizing the resistance?
In terms of natural products?
Just here, it's natural antibiotic products. So because this is, yeah.
Okay, yeah, so that's a tricky question. When we look at what we would call alternatives to antibiotics or natural products, anything that has a selective pressure on the organism will lead to resistance. It's just how nature works. You put pressure on something, it will develop resistance. So it doesn't matter if it's a natural product, if it's classed as an alternative, as long as the molecule has direct activity on the bacteria, there is a chance you will at some point in time see resistance developing. Okay?
Okay, thank you.
No problem.
I'm still يعني برضو بشجع الزملاء لو في أي أسئلة حضراتكم عندكم الشات بوكس، حضراتكم ممكن تحطوا الأسئلة او to raise الكويشنز اللي حضراتكم حابينها او to discuss اي بوينت مع السبيكرز النهارده ان شاء الله. سو ننتقل الان للمحاضره الثانيه مع دكتور هينينجا. والمحاضره دي مهمه جدا لان دكتور مارك هينينجا يعني هي will take the lens wider and will give us more and more information about resistance, but from a global perspective. ف برضو بفكر حضراتكم لو في أي أسئلة. دكتور مارك, please, we are all yours.
Okay, can you hear me?
We hear you and we see the presentation.
Okay, perfect. I'm just looking for the pointer. Okay. One second. I don't know if I didn't get that. Sorry. You see the presentation? Okay. Okay, so good morning, everybody, and thanks to the organizer of this meeting. So we have seen some important component of antimicrobial resistance with Dr. Shabir, and now we'll go on global regulation and global guidelines mainly, and how to tackle antimicrobial resistance and to build antimicrobial stewardship. So Dr. Schaps show in his presentation this document, and just to say that there are a lot of NGOs and organizations publishing guidelines to tackle antimicrobial resistance. But really important here to understand is that these are guidelines and they are not legally binding, but they are tools that can be used by people who want to implement their national action plan. And so here I will first explain you how you come from these guidelines to your national action plan. So global guidelines anyway influence national action plan. Why? Because if you have two kind of guidelines. I'm sorry. I have an issue. There is some echo.
No, now it's okay.
Okay. So you have mainly WHO who published several documents. So the Global Action Plan, also categorization of antimicrobials important for human health, for the use for non-human use, that is updated every 2-3 years. Also guidelines on the use of these medically important antimicrobials in food animals. WHO influence is very significant because they are part of the United Nations and they are also close of Ministry of Health. And in many countries, the influence of Ministry of Health is important, not only on human health, but sometimes also on animal health. More important for us would be OIE, because OIE published its own list of antimicrobials, but antimicrobials important for animal health, the one we need if we want to take care of the health of animals. Also, the terrestrial code provide guidance for responsible use of antimicrobial and is updated on a regular basis. Influence of OIE is great in countries where veterinary services are well developed and where there is a more balanced relationship between Ministry of Agriculture and Ministry of Health. So it really depends on countries. Also important to notice is the food chain, because more and more in different countries, food chains and retailers, for example, tend to follow WHO guidelines. Why? Because as they are a global company, they want to use global guidelines. But this is not always the case, and it is, to our opinion, not relevant. So, sorry. I have some issue here. Okay, so from global action plan to national action plan. So most of the time, Ministry of Health in the country is in connection with WHO and has to set up a national action plan. What they do is that they take into account, for example, OIE and so on. And also they can take into account opinion of NGOs or also WHO categorization of medically important antimicrobials, WHO guidelines. And at the end of the day, you have two scenarios. One is the country set up antimicrobial usage monitoring. They also are equipped to do a good antimicrobial resistance monitoring, what has been shown by Shabs earlier. They are able to do their own risk assessment. And what is the consequence of that is that they will have a fit for purpose national action plan. I mean, a national action plan that takes into account both. Then they can publish local guidelines and categorization and also regulation in some cases. The other scenario is that there are limited resources for antimicrobial resistance monitoring or risk assessment in animal health. So the risk here mitigate if even if there is no local risk assessment by taking into account European regulation, for example, or European categorization of antimicrobial, what we call AMEC categorization, or Japanese or whatever you want. But important is to keep in mind is that if we want.
Mark, we are losing you. Shall you stop your video, please? Because this might be an issue for the connection. Dr. Demirdash, do you have also the same problem of the disconnection?
Yes, yes.
So, Mark, if you can, Mark, please. No, we don't hear you. You are muted. Just stop your video, please, and share the presentation again because we have some. We are losing you.
Okay. When did you lose me?
Okay, in slide number 4.
Okay.
Yes.
So I think I was at the end of slide number 4, okay?
Correct, correct.
Okay, good. So I'm sorry for this poor connection. What other steps are being taken to reduce antimicrobial resistance? So categorization of antimicrobials is a key point. It has to be done locally, but it's important for you to also to know what has been done globally and in different areas, and I will talk about that. Also, guidelines on use of medically important antimicrobials is an important piece of work that we will discuss, and then we'll finish with antimicrobial stewardship. So categorization of antimicrobials. The most known is WHO categorization because it has been published since the beginning of 2000. And so it's ranking of antimicrobial for risk management. It presents medically important antimicrobials on one side and non-medically important antimicrobial on the other side. So it's very well known, but it's not the only categorization. Overall, you have two categories of antimicrobials. You have what we call medically important antimicrobials and non-medically important antimicrobials. Medically important antimicrobials are antimicrobials used both for human and animals, or antimicrobial used only for humans. Non-medically important antimicrobials are what we call also animal-only antimicrobials. They have been developed for animals, and in some cases also they cannot be used in humans because animals and humans are quite different. And so these antimicrobials cannot be, because there is adverse effects, and they cannot be used in humans. So they are kind of reserved for animals. So medically important antimicrobials are classified by WHO as important, highly important, and critically important. And here you see a lot of and what they call animal-only antimicrobials in the Annex 2 of this categorization. And I'm really sorry about that. Can you still?
Mark, we see it, but we are losing you. So we apologize. I will just try to contact Dr. Henninger to see how can we troubleshoot this. Give us a few seconds, please.
Hello, can you hear me?
Yes. Now, yes.
Okay, I'm really sorry. So animal-only antimicrobials with molecules like avilamycin and also the family of ionophores. So they are important for animal health, and they are also safe for human. And so we do consider that avilamycin, for example, and ionophores are part of the solution to fight antimicrobial resistance in animal and human, because they help to reduce the use of what we call medically important antimicrobials. I also want to quickly present European categorization. So this has been developed recently. It has been published beginning of 2019. It is ranking of medically important antimicrobials and also ranking of route of administration. This AMEC categorization has been developed and to be used together, the ranking and the route of administration. It's a tool for European countries and also for other countries because it's publicly available. Important to notice is that here they don't use the wording of important antimicrobials. They rather discuss about 4 categories. Avoid mainly are antimicrobials that have currently no market authorization for animals, so they are only used for humans. Restrict are some antimicrobials that are important for animals and humans, but that should be used with caution. That with restriction, I would say, but that again is not binding, it's just suggestion. Caution are antimicrobials, antibiotics that should be used when there is no antibiotic available in the last category, which is prudence. And so it's an intermediate category between prudence and restrict. The route of administration globally consider, and I think it's common sense, that local individual treatment is less at risk to generate antimicrobial resistance compared to oral route of treatment. And so recommendation of AMEG is to use both the categorization and route of administration, and for sure antimicrobial resistance monitoring at country level and risk assessment to set up guidelines at local level. What you can see here is that there are discrepancies in categorization between global, regional, and national level. Just here 2 examples. And you see that WHO, European Medicine Agency, France, Japan, just some example, all agree that cephalosporin are very important, both for human health and animal health, so should be used with caution in animals as to preserve their efficacy and limit the risk of transfer of resistance to human. But if we look at polymyxin, colistin, which the WHO considers them as highest priority, critically important antimicrobials. European Medicine Agency too, because they are categorized as B in EU in the AMEG categorization. Japan, same, but France, no. Why? Because France did its own risk assessment on colistin. They looked at antimicrobial resistance of bacteria, what bacteria are resistant to colistin, and they did consider that compared to other options, polymyxin should be kept. Doesn't mean that it will be considered for years this way, but they will monitor resistance, and if something change, maybe they will recategorize colistin, but at the moment, they decided not to do so. And so polymyxin and colistin is not considered as critically important antimicrobials in France. I leave the floor to Ahmed El-Demerdash to
Thank you,
do a summary.
For this part, الجزء اللي اتكلم عنه الدكتور مارك اتكلم عن التصنيف العالمي للمضادات الحيوية وأشار للتصنيفات المحلية كمان في بعض دول العالم زي فرنسا واليابان وغيرها للمضادات الحيوية. والتصنيفات دي بتستخدم كقواعد إرشادية للاستخدام الأمثل للمضادات الحيوية. أهمية التصنيفات إنها بتحد من ظاهرة المقاومة البكتيرية، لكن بنلاحظ وجود بعض التناقضات في التصنيفات الحالية. فممكن نلاقي نفس المجموعة ذات أهمية قصوى في تصنيف منظمة الصحة العالمية ولا يكون كذلك في تصنيف الوكالة الطبية للاتحاد الأوروبي. مراقبة المقاومة البكتيرية على المستوى المحلي ومدى توافر المضادات الحيوية لاستخدام الإنسان والحيوان هيكون له أهمية لإيضاح تلك التصنيفات. إذن على المستوى المحلي مراقبة المقاومة البكتيرية ومدى توفر المضادات هو الأساس اللي على أساسه هنقدر نوضح التصنيفات العالمية الأخرى. أوكي دكتور مارك.
Okay, thanks. So now I will present some guidelines and especially WHO guidelines. It's not that we consider that they are fit for purpose for animal health, but it's important to know that it does exist, okay, and what is in it. So first, two definition, growth promotion and therapeutic use. It's important because WHO guidelines give some advice or recommendation about the use of the different categories of antimicrobials for growth promotion. So growth promotion, everybody knows what it is. It is the use of antimicrobial to improve feed conversion or growth of animal. It is different from therapeutic use that we define as prevention or prophylaxis, meaning use of a medicinal product to an animal before clinical sign of a disease. Therapeutic use also include what we call control or metaphylaxis, which is the administration of a medicinal product to a group of animals after a diagnosis of clinical disease in part of the group has been established. Metaphylaxis is really the way we use antimicrobials in animal health most of the time, especially in poultry. Treatment is administration of a medicinal product to animals to treat clinically sick animals only. It's the way we use antimicrobials for human usually, because we don't treat group of humans. It's also the way we use it for pets, and it can happen we do that for a group of animal for individual animal in cattle, for example. But for poultry, mainly the use is metaphylaxis. So what recommend WHO? So for sure, they say that we should reduce the use of all medically important antimicrobials in food-producing animals. So as said, chaps, yes, it makes sense that even if you can have resistance without using antimicrobials, the more you use, the more you put pressure on them. So it's common sense to say that we should try to reduce the use of medically important antimicrobials. Other things, they ask for the ban of medically important antimicrobials for growth promotion. That's interesting here because they don't, they kind of don't care about Annex 2 non-medically important antimicrobials that are still used in some country for growth promotion. They ask also for restriction of use for all medically important antimicrobials in food-producing animals for prevention of infectious disease that have not yet been clinically diagnosed. Again, that's the way WHO recommend to use medically important antimicrobials. Going forward, they say that critically important antimicrobials should not be used for control, metaphylaxis of disease, and that highest priority critically important antimicrobials should not be used for treatment of food-producing animals, even for treatment. Important to know those guidelines and also to discuss those guidelines. So the question here is, are WHO guidelines relevant? So it's a very personal opinion about that. But also that all animal health industry globally share is that if we should apply WHO guidelines on the use of medically important antimicrobials in food-producing animals, it would be detrimental for animal health and animal welfare. Because a lot of antimicrobials, a lot of disease, we need to use antimicrobials. We need to use them for prevention, we need to use them for control and for treatment. So it gives a big picture, but we should not apply that as you know, a reference. Interesting also to know is that EU regulation on VMP intend to fight antimicrobial resistance. That's one of the main objectives of the new EU regulation from 2019 that will enter in force in January 2022. But EU do not apply WHO guideline on use of MIA in its new regulation. So they didn't make a copy paste of recommendation of WHO in the guidelines, in regulations that has been published in 2019. For example, EU regulation allows the use of medically important antimicrobials, including HPCIA, for prevention, metaphylaxis, and treatment, even if they recommend good judgment, and we'll see that later for prevention. It is important to consider, instead of WHO guidelines, OIE guidelines that have been developed for the sake of animal health. OIE published first its own list of antimicrobials important for animal health, and this includes highest priority CIA, and OIE also provide guidance for responsible use of antimicrobials through the terrestrial code. And so terrestrial code is a good tool to use when Ministry of Agriculture with stakeholders want to discuss and set up antimicrobial stewardship in the country or in an organization or in a poultry company, whatever. So, Ahmed, if you want to summarize.
Okay, مارك. زي ما شرح الدكتور مارك عن التقارير واللوائح اللي عاملاها منظمة الصحة العالمية، موقف الاتحاد الأوروبي والمنظمة العالمية لصحة الحيوان كان لها موقف من معايير منظمة الصحة العالمية. الاتحاد الأوروبي لا يطبق معايير منظمة الصحة العالمية للمضادات الحيوية المهمة والغاية في الأهمية للاستخدام الحيوانات المنتجة للغذاء، بيطبق معايير بيستنبطها من الواقع المناسب للاتحاد الأوروبي. الاتحاد الأوروبي التنظيم رقم 6 لسنة 2019 بيسمح باستخدام المضادات الحيوية المهمة والغاية في الأهمية في الوقاية والعلاج للحيوانات المنتجة للغذاء. المنظمة العالمية لصحة الحيوان وضعت معايير هي الأخرى للمضادات الحيوية المهمة والغاية في الأهمية، والتي وضعت ضمن لستة استخدامها للعلاج وللوقاية للحيوانات. وهنا بعيد نفس الملخص العربي اللي قلت المرة اللي فاتت. المعيار المحلي لتوافر المضادات الحيوية هو المعيار، والريزيستنس اللي بيحصل على المستوى المحلي هو المعيار لفهم توصيات منظمة الصحة العالمية لمعايير استخدام المضادات الحيوية المهمة والغاية في الأهمية. أوكي مارك؟
Okay, thanks, Ahmed. So now let's talk about antimicrobial stewardship. So the idea in this part is, how can I preserve antimicrobial efficacy for both humans and animals while protecting animal health and welfare? So going forward with WHO guidelines, I told you that they, for example, ask for reducing very hardly the use, but the good news is that even WHO, which is very strict, but no restriction of use for animal only. So products like avilamycin or bobbermycin or carbadox, there is no restriction on the use of animal-only antimicrobials, either for prevention, control, or treatment. So that's a good way also to fight antimicrobial resistance, is that when you have an antimicrobial that you can use, you should first start by animal-only. The example of avilamycin is interesting because it is safe for consumers, and you see here an extract on the screen that was done for the MRL in Europe of avilamycin. And one of the quote here is that, why is it safe? It is safe because there is no evidence of in vivo transfer of resistance, and there is no human reservoir of avilamycin resistance, because avilamycin has a unique mode of action and show no cross-resistance with other antibiotics. That's the safety for antimicrobial resistance. That's the reason why when you have bacteria sensitive to avilamycin, it should be used. For sure, avilamycin will not be useful to treat respiratory disease. It's only for intestinal disease. But if you can use it, you should use it. And avilamycin also, as MRLs are approved at Codex, FDA in US, in Brazil, Japan, Morocco, EMA, and a lot of countries. It is currently used for prevention, treatment, or control, depending of local regulation in more than 40 countries in the world. And just to make a summary, compare also to all the molecular use for infectious disease, you see that it is not used in human medicine. It is not important for human medicine. There is no restriction of use as feed additive by WHO, and MRLs are approved by Codex. And if you look for other molecules, for example, like colistin, you see that it is used in humans. It is HPCIA for WHO. It is recommended not to be used as feed additive, and nevertheless, there are MRLs approved in Codex. So just an example of the importance of animal-only antimicrobials. As a kind of summary of antimicrobial stewardship, I think based on these WHO guidelines, nevertheless, what they say, even if they would ask to more restriction, what they say is basically common sense again. They say, well, start with animal only if you have some. Then, if animal only is not available or not efficient because it's intrinsically resistant, then use antimicrobials from the important category. Then, if it doesn't work or it's not available, then use highly important, then critically important. And lastly, use highest priority, critically important antimicrobials. That's the overall idea, I think, that we need to keep in mind. It will depend also on the availability of antibiotic, of resistance pattern or result of antimicrobial sensitivity testing in the country, and also of the route of administration that can influence the choice, because not all antimicrobials are available. For example, if you want to do a group treatment, you may not use cephalosporin because there is no cephalosporin available for medicated feed. So if you need to treat a group, never you will use cephalosporin or fluoroquinolone. Last part of I want here is to give you an update on EU regulation. One is not recent because it's from 2003, it's a feed additive regulation, but two are more interesting because, as I told you earlier, they will enter in force in January 2022. Regulation EU 2019-4 is a regulation that we call medicated feed regulation, and regulation EU 2019-6 is the veterinary medicinal products regulation. And I will present you very briefly these three regulations. So first one is the feed additive regulation. In this regulation, you can see the definition of feed additive, and overall, it's any substances, microorganisms, some probiotic enzymes, whatever you can add in the feed to improve the feed, and also that have some impact on the characteristic of feeds, also the characteristic of animal products. Sometimes you have also products added to improve the color of fish or birds. It can help to satisfy nutritional needs. It can also improve performance or welfare by improving gastrointestinal flora or digestibility. Here you have enzymes. And also important to notice is that molecules having coccidiostatic or histomonostatic effect, either from chemicals or from biological origin as ionophore, are regulated as feed additives. That's quite important in EU because that means that poultry producer has a free access to ionophores. There is no vet prescription. And that's something that I wanted to tell you because sometimes regulation may differ from country to country. So in EU, in all member states, ionophore coccidiostat are feed additives. Regulation 2019-4 is the medicated feed regulation. So, for example, it will not apply to ionophore because ionophore is regulated by feed additive regulation, even if they are administered to animals through feed. So this regulation will apply 28th of January in all member states. They define medicated feed as a feed. So they do consider that medicated feed is a feed which is ready to be used and fed to animals. And it's a mixture of one or more VMP with feed materials. That's quite important. It means that VMP regulation apply until it is mixed with the feed. And then it's a medicated feed regulation that will apply. Medicated feed is authorized in EU and still will be authorized in January as a route of administration for antibiotics, antiparasitics, and immunological products. And it also applies for pets and food animals. And that's something new in this regulation. It's that it applies for pets because some pets, you have chronic disease and some people want to use feed to give treatment every day. It can be for arthrosis or for cardiac issues or things like that. Veterinary medicinal products that are incorporated in medicated feed must be authorized to this usage. So, for example, if I take the example of Thailand, you will have Thailand premix that is only to be used to manufacture medicated feed, and you would have Thailand soluble that is to be used in water. And in no case you will use Thailand soluble in the feed. So you have a specific formulation, which is Thailand premix, and that is used for medicated feed. Last but not least is that for medicated feed, as for VMPs, veterinary prescription is mandatory. That's something specific maybe in EU, because it's not the case for a long time. For example, in US, I think that for medicated feed, you have kind of a prescription, but only for 2-3 years. In EU, it's mandatory for a while, but I can tell you by experience that even when I started in feed mill some years ago, more than 20 years ago, a lot of trucks were leaving the feed mill without vet prescription. So no, it's a case, but it's something that has been implementing during the last 10 and 15 years. And it's not something easy to do, but that anyway is EU regulation. For regulation on veterinary medicinal products, so 2019-6, it will apply same day, 28th of January 2022. It applied to veterinary medicinal products, and clearly it does not apply to feed additives, as we have seen before. Definition of veterinary medicinal product can be interesting because I think it's meaningful. Most important VMP are products that have property for treating or preventing disease in animals. It's important to notice that, because if you have something that could help probiotics or things like that, if you want to claim that your probiotic is customer should use it to prevent a specific disease, then you should register it not as a feed additive, but as a VMP. So difference between VMPs and feed additive is the objective of the product. That's very important. Important definition you can find. So I will go fast here because I think you already seen it with sharps. I will just insist on one thing. Is that, for example, if I take antibiotic, it's any substance with a direct action on bacteria, but that is used for treatment or prevention of infections or infectious disease. I do insist here because if, for example, I use a product that have some antibacterial activities, for example, I use it in the water of animals, like bleach or other acidifiers, just to treat the water. This product have antibacterial activities, but they are not designed, and there is no claim about the fact that they can prevent or treat a disease. So they are not considered as an antibiotic. So legally speaking, that's very important to understand that. And that's the case also for antimicrobial and antiparasitic. There is the idea of they are active, but they also are used for treatment or prevention. Metaphylaxis, I already discussed that, and prophylaxis is well defined in Regulation 2019-6. And I think it's interesting for everybody to know that these definitions are available, publicly available, because they can be used. And I think they are, yes, well designed, and it could be interesting to do some copy paste of this definition in local regulation or guidelines that could be developed by some stakeholders. Now we come to EU Regulation 2019-6 and antimicrobial resistance. And I will insist on the three main articles that are related to antimicrobial resistance. So you have Article 37, and what says this article is that EU will publish a list of antimicrobials or groups of antimicrobial reserved for treatment of certain infection in humans. First thing, this list is not published yet. It's still under discussion. Experts of the European agency are still working on it. What is important to know is that it may include some HPCIA, for example, colicin, but there's nothing sure about that. Why? Because they may be included in the list of antimicrobial reserve for human only if they are not important for animals. There's been a debate about that. I mean, the criteria to establish the list have been published, and they insist on the fact that molecules, antimicrobials reserved for humans, should be both important, kind of critical for humans, but also that if they are critical for animals, that we need them to treat or prevent or control disease in animals, then they should not be reserved for humans, because they are also important for animals. So that's really important to understand. This list will be binding, meaning that antimicrobials in the list, even if at the moment they have a market authorization as VMPs, they will lose their market authorization as soon as the 28th of January next year. But this list is different from AMEG categorization. AMEG categorization only provides recommendation, and so it will not be a copy-paste. We think that antimicrobial categorized in a category, meaning that they have no market authorization today for animals, they will be in this list, but there may be others or maybe not. We are waiting about that, but that will be the only, I would say, ban of antimicrobials potentially in EU. Second important article is collection of data on antimicrobial medicinal products. At the moment, you have an antimicrobial resistance monitoring program that is mandatory in every member state, but the monitoring of usage is not mandatory. Starting in January 2022, it will be mandatory. Implementation will be progressive, meaning that the first report should be published in 2024. And also interesting is that to avoid any confusion, because you have some molecules that could be considered as VMPs, antimicrobial VMPs or not, what they decided is to publish a list of ATCV code categories that should be collected. And that's an important tool because you have some important molecules that have that are not important for antimicrobial resistance, that are VMPs, and that will not be in the data collection. And last article important for antimicrobial resistance in this regulation is Article 107 about the use of antimicrobial VMPs. So I would say it's kind of the same as WHO guidelines, I would say, okay, that I presented. So here they ask the ban of the use of antimicrobial VMPs for growth promotion. That's in this article. And also there is some restriction on prophylaxis based on the judgment of the veterinary practitioner. So prevention is possible when the risk of an infection or an infectious disease is very high and the consequences are likely to be severe. So they ask to restrict prophylaxis, but still this regulation says, okay, if you believe the risk is really high and the disease is very severe, then you can go and use any medically important antimicrobials for prophylaxis. And that's it, mainly about EU regulation and antimicrobial resistance. So Ahmed, I leave you the task of summarize in Arabic.
في الشق اللي اتكلم عنه دكتور مارك اتكلم عن التنظيمات اللي خرجت من الاتحاد الأوروبي من 2003 إلى يومنا هذا. خرجت 3 إصدارات تنظيمية من الاتحاد الأوروبي للأنواع التي تستخدم في الحيوانات. الإصدار رقم 1831 لسنة 2003 والذي يختص بالإضافات العلفية كالمواد والتركيبات والبروبيوتكس الكائنات الدقيقة والإنزيمات ومضادات الكوكسيديا. الإصدار الثاني اللي هو رقم 4 لسنة 2019 والذي يختص بالمعالجات التي تضاف على العلف للوقاية والعلاج من العدوى البكتيرية أو الطفيلية للحيوانات التي تنتج الغذاء ولعلاج الأمراض المزمنة بإضافة تلك المعالجات على العلف للحيوانات الأليفة أيضا. والإصدار رقم 6 لسنة 2019 والذي يشمل كل المستحضرات البيطرية والمضادات الحيوية واللقاحات ومضادات الالتهابات وخلافه. وهذا الإصدار أدخل صور جديدة لمفهوم المقاومة البكتيرية للمضادات الحيوية للاتحاد الأوروبي. حصرت بعض المضادات للاستخدام البشري. المعالجات، هناك طبعا فرق ما بين الإضافات العلفية وما بين العلف المعالج. إضافة المضادات الحيوية على العلف غير محظورة، ولكن تستخدم بالجرعة المناسبة. يعني إذا كانت الجرعة 5 أيام تضاف على العلف، لابد أن تؤخذ لمدة 5 أيام، لأن السب أوبتيمال دوز ممكن يسبب مقاومة للبكتيريا. فاستخدام المضاد الحيوي بأي روت، سواء عن طريق المية أو عن طريق العلف، لكن بالجرعة المحددة وبعدد الأيام المحددة، حتى لا تكتسب البكتيريا أي مقاومة للمضادات الحيوية. الاستخدام لأي مضادات حيوية سواء على العلف أو سواء في الماء لابد أن يكون تحت الإشراف البيطري من الأطباء البيطريين. أوكي مارك؟
Okay, thanks, Ahmed. Okay, so now the conclusion of this part. So first, I want to highlight that antimicrobial resistance is a real and key issue that must be addressed in every country, both in animal and human. But the priority should be to reduce the need for antimicrobials. So I think that vaccines can help, but good husbandry also can help. That's the first priority for animal. And on the other hand, and we have this discussion sometimes in France, reduce the need for antimicrobials in hospital. Sometimes it can. Some people think it's crazy, but just by insisting on the fact that nurses and doctors wash their hands more often, you can reduce the risk of infection, and that it's common sense, but nevertheless, they did it. The materials, there has been publication on that. So it's very important to reduce the need for antimicrobials, and a good hygiene, both in hospital and in farm, can help to that. Third point is that responsible use guidelines should consider both global and local categorization, because as you have seen in my presentation, there are discrepancies. And the reason why there are discrepancies is because local categorization is based on real life, and that's the best things to do, and the best way to have any antimicrobial available. Categorization of antimicrobial is key and should be part of a national action plan based on local risk assessment. If we look at the guidelines, WHO guidelines on use of medically important antimicrobials in food-producing animals would be detrimental for animal health. And I just want to insist on the fact that EU regulations are not a copy-paste of it, but we may keep in mind the big picture with, starting with animal only and then later up. The list of antimicrobial reserve for human that has to be published soon by EU takes into account both the importance for human health and the importance for animal health. And that's why it's also important to have Ministry of Agriculture involved in the National Action Plan, and that Ministry of Health listen to them, because otherwise Ministry of Health may only keep a recommendation of WHO, and then we will have big trouble with farm animals. And so already there is a need to find a good balance between WHO and OIE, between human health and animal health. And that's a nice thing with EU regulation at the moment, is that, and even if there has been debate, because some people didn't want to consider animal health, but at the end of the day, said, yes, we cannot just deprive animal health from some molecules. So that's very, really important. And last is that non-medically important antimicrobials that we call sometimes animal-only antimicrobials should always be first choice, and then ladder up, as I already said. And Ahmed, I leave it to you for a summary now. شكرا everybody.
Thank you, Mark. في الشق اللي اتكلم عنه دكتور مارك كخلاصة للمحاضرة ككل، إن المقاومة للمضادات الحيوية واقع يؤخذ في الاعتبار. الأساس لمعالجة أو لمقاومة المقاومة البكتيرية للمضادات الحيوية هو الاستخدام المسؤول للمضادات الحيوية تحت الإشراف البيطري. تصنيف منظمة الصحة العالمية للمضادات الحيوية وإصدارات الاتحاد الأوروبي وإصدار المنظمة العالمية لصحة الحيوان تعطينا صورة لرؤية من أكثر من زاوية لصحة الإنسان والحيوان، ويبقى التطبيق على أرض الواقع يحتاج لفهم أكبر لواقع كل بلد ولحالة المقاومة اللي موجودة على حسب السيرفي اللي بتتعمل من آن لآخر.
شكرا.
Thank you.
شكرا دكتور دمرداش على السمري. Thank you, Mark, for this very comprehensive overview about different regulations. As we're still with you, Dr. Heringa, please, we have important question here from Dr. Ihab Ahmed about what I know that you covered part of it in your presentation, but what is the role of Elanco in combating antimicrobial resistance worldwide?
Okay, thanks for your question. The role of Elanco. Elanco, as an animal health company, is both part of the problem and part of the solution, as we always say. Part of the problem because if we consider that using antimicrobial is responsible for resistance, then we are producing antimicrobials. So we are part of the problem. But we also are part of the solution because antimicrobials are used to take care of animal health. Nevertheless, we try to globally to educate people on responsible use of antimicrobials. That's one of the action we do. Another action is that we developed a portfolio of vaccines, and we still are developing them because we think that sometimes with vaccine, you can prevent disease and reduce the need for medically important antimicrobials. We also developed and really develop animal-only antimicrobials because we want to develop the usage of animal-only antimicrobials instead of medically important antimicrobials. So this portfolio of molecule, we are proud of it, and we want really to support it. That's also important because they are not involved in antimicrobial resistance, but they help to reduce the use of MIA and so reduce antimicrobial resistance. And last but not least, we also developed for some years nutritional health products that are feed additive that can be added in the feed, and that will help to have better intestinal integrity. And so it contributes to avoid the need of antimicrobials. Maybe, Shabs, you can add some things about that, because I know you have been involved in our global action plan on antimicrobial resistance.
Yeah, sure. Thanks, Mark. So on top of what Dr. Mark has alluded to, Elanco has a responsible use guideline. We have just released it earlier this year. So we had a responsible use guideline from 2014 until 2020. And we've just released our new 10-year responsible use guideline. Again, it doesn't say we need to eliminate antibiotics in veterinary medicine, but it's more about the responsible use pathway. And it's suggesting to use less medically important antibiotics or antibiotics lower down on the WHO's critically important antibiotic list, and then working your way up the list in a cascade system. We've got clear definitions on prevention, treatment, control. And in all instances, we would advocate the veterinary intervention or veterinary assessment before antibiotics are administered. It doesn't matter if it's for treatment, control, or prevention, but veterinary oversight would be fundamental within our antibiotic stewardship guideline.
Thank you. Another very important question, which really goes to our daily life. Even we see some debates in the hospitals about this. And this might be for you, Dr. Shabir. What about the relationship between biocides, heavy metals, and antibiotic resistance?
Yeah, no, that's a good question. We did a lot of work, or I did a lot of work in the 1990s, early 2000s on both heavy metals and biocides disinfectants. There's a lot of evidence that we have co-selection of resistance. So where I showed multiple resistance genes, so either co-selection or co-resistance to heavy metals, disinfectants, and biocides linked to antibiotic resistance genes. We see that predominantly a lot within the hospital setting with disinfectants and biocides. We see a lot biocides and heavy metals in the veterinary setting, especially copper resistance linked to antibiotic resistance. So there is a big correlation between antibiotic gene linkage of antibiotic resistant gene linkage and gene linkage to biocides, heavy metals, and detergents and disinfectants.
Thank you. Another question. What is the role of cross-resistance in the spreading of antimicrobial resistance?
What's the role of cross-resistance? So cross-resistance is resistance to one antibiotic giving resistance to other antibiotics in the same class. That's the strictest definition. We see that a lot in a lot of antibiotic classes that are what we would call shared class. So they're medically important, but they're used both in humans and animals. And not every antibiotic will give you that level of cross-resistance. So for example, you could use first, second generation cephalosporins in veterinary medicine and get cross-resistance to first, second generation cephalosporins used in human medicine. But that first, second generation resistance doesn't give you cross-resistance to fourth and fifth generation, as an example. If we go down into more granular detail, you do get cross-resistance between different antibiotic classes in some cases. So for example, recently we've had a new gene emerge called CFR, and that gene gives you resistance to lincosamides. But if you're not using lincosamides in veterinary medicine, where are you getting that resistance gene from? It turns out that CFR also gives you cross-resistance to streptogramins. So this is drugs like virginiamycin. So by using virginiamycin, you create resistance also to lincosamides. So cross-resistance is actually a very important route of spread of resistance, not only to antibiotics in the same class, but in some cases, antibiotics of different classes.
Very good, thank you. I think we have very interesting question here from Dr. Mahmoud Rabia, is asking, as we have now more and more antibiotics that bacteria develop resistance against it. The question is, how can we use these antibiotics to obtain the best results? I believe in terms of performance, and in the same time to minimize the risk of AMR.
So during my talk, I alluded to a FAO study across Asia, where we looked at resistance prevalences. And I mentioned that resistance to a number of antibiotics was lower in Asia compared to Europe and the US, despite there being more antibiotic use and more less controls on the antibiotics being used. I'm a strong believer that the reason we see less resistance is not because of less antibiotic use, but by rotations. We're doing that more and more on the human side as well. And I think if you can rotate antibiotics at regular frequency, so it doesn't have to be monthly, quarterly, could be every 6 months, could be once a year. But if you use different antibiotics of different mechanisms of action, so for 6 months, you use a cell wall inhibiting antibiotic. 6 months, you use a protein synthesis inhibitor. 6 months, you use a biochemical pathway blocker. using different mechanism of action antibiotics gives less selective pressure for resistance development. So I'm a big advocate for rotation programs. And I think that's what's happened across Asia, that farmers, because of so many generics being available and the competition between the suppliers, farmers inadvertently, without knowing, they've been doing a really good rotation program just because of the pricing differences between the companies. And that's probably one of the reasons that's kept resistance low in Asia. So I think rotation, but it has to be with antibiotics with different mechanisms of action. It's no point changing a protein synthesis inhibitor with another protein synthesis inhibitor. It has to be different mechanisms of action that will really help reduce the emergence and spread of resistance.
Thank you. Also, another very important question here from Dr. Ihab Ahmed regarding fosfomycin. I believe because fosfomycin is being used in human medicine since a long time now, and he's asking, is there any public health risk of using this fosfomycin in the treatment of pet animals?
Yeah, so fosfomycin is an interesting drug. It's a phosphonic acid. It was very popular years ago, and then we use very little of it in human medicine. But in the last 3-4 years, fosfomycin's become very popular again in human medicine, mainly for UTIs as an oral therapy. It's also used as an inhaler for respiratory infections as well. And some of that's because of COVID. It's gained quite a bit of popularity. It's a very good drug. And I think what's going to happen now, as fosfomycin gains more importance in human medicine, because we don't see that much resistance on the human side at the moment, primarily because we've not used it for a long time, you will start seeing pressure on fosfomycin in the veterinary sector, because you do see resistance development. And there's always a possibility that the bugs, especially in companion animals, so cats, dogs, those are going to be more dermal pathogens, commensal pathogens on the animal skin. They will transfer more easily to humans. They then have the potential of causing respiratory infections more than UTIs, obviously. And if we're going to depend more on fosfomycins as an inhaler on the human side, it's going to start having pressure on trying to reduce it in the veterinary sector.
I'm hoping that I'm not overlooking any question, but I have also very important question here from Dr. Ahmed Youssef. This is the $1 million question, I believe. So what is the best strategy to overcome the multiple drug resistance without losing the flock performance?
Multiple drug resistance. Yeah, the problem is it depends on where the multiple drug resistance is being located. So the example where I gave fluoroquinolone resistance in the USA, continuing to increase despite the drug not being used for over a decade. The reason for that is that the mechanism of resistance is chromosomal. And as I mentioned earlier, chromosomal resistance is very unlikely to be reversible. Once it's there, it's present. Luckily, the majority of the drugs that we have to which there's resistance is either plasmid, integron, or transposon mediated. Those are costs related to the organism. So as long as there is sufficient time, and we don't know what the time is. For some drugs, we've seen resistance being lost very, very quickly. For some drugs, it takes decades for us to lose those mobile genetic elements. But again, having a good rotation programs where you don't have resistance to the drug on mobile elements or not present in large prevalences in the bacteria would probably be the best way to try and not only reduce, but have a chance of getting rid of existing mobile DNA elements in the pathogens. But it's not something that's going to be able to just vanish overnight. Even a strategy of rotating drugs for which you have low prevalence of resistance doesn't mean that existing resistant patterns will go away quickly. So if we look at plasmids don't only carry resistance to antibiotics. They have tolerance to heavy metals, they have UV tolerance, they convey all sorts of benefits to the bacteria. So even if you were to eliminate antibiotics, if that plasmid gives protection from UV light, then it's in the bacteria's benefit to keep the plasmid. So it's not something that's going to happen overnight. Even if you stopped using antibiotics, it could take decades for those mobile elements to vanish.
All very important and really interesting questions. Hope that we didn't miss any of these questions. Dr. Demirdas, do you have any comment from your side?
ثانك يو دكتور احمد. انا بس اعلق على احد الاسئله المهمه عن دور إيلانكو في مقاومه البكتيريا. وزي ما تفضل دكتور شبير ومارك ان إيلانكو عندها وايد رينج اوف برودكت بروبايوتيك ترندس فاكسينز، بالاضافه الى التوعيه والريجوليشن اللي بتعملها إيلانكو للاستخدام الامثل للمضادات الحيويه، الجرعه المناسبه، ومع مراعاه الوزدرول بيريود اللي تهم الانسان. دي من النقاط المهمه اللي بتقوم بها إيلانكو على المستوى المحلي وعلى المستوى العالمي، بالاضافه ان إيلانكو عضو في جميع المنظمات العالميه اللي بتختص بالاستخدام الامثل للمضادات الحيويه، وبتنقل الخبرات والنيو ريجوليشنز اللي بتطلع اول باول على المستوى المحلي في جميع دول العالم. السؤال الثاني اللي عايز اعلق عليه اللي هو مقاومه ايه التعامل الامثل عشان ما نفقدش الفلوك برفورمانس لو حصل فيه دراج ريزيستنس. ان احنا نختار زي ما تفضل الدكتور شبير ان يكون في روتيشن، بالاضافه ان احنا نستخدم المعمل ونعمل اختبارات حساسيه ونختار المضاد الحيوي المناسب بالجرعه المناسبه. اكتر شيء ممكن يعمل دراج ريزيستنس اللي هو السب اوبتيمال دوز، يعني الجرعه المفروض تتاخد في 3 ايام، اذا اتاخدت في يوم والطيور او الحيوانات او حتى على مستوى الانسان كويس، معنى كده ان هيتبقى في جسمه مضادات حيويه ميكروبات وهتكتسب مقاومه مع الزمن. فالجرعه الاوبتيمال دوز مهمه جدا بالروت المناسب مع الاختيار المضاد الحيوي المناسب.
شكرا دكتور دمرداش. I think ان احنا وصلنا لنهاية المناقشة. فدكتور علي لو حضرتك حابب تلقي أي كلمة.
First of all, great thanks for Dr. Shabir and Dr. Mark for valuable presentation. As you know, AMR is the one of major headache of the world. We have a big task and the duties in our local and international efforts to address this issue. As you know, AMR will affect on global GDP, global poverty, also world trade, healthcare costs, and livestock outputs by 2050. Maybe some veterinarians and poultry farms ask why Saudi Arabia banned the use of colistin in poultry farms. The answer: colistin is considered by international organizations as a last resort to treat incurable human disease. Here in Saudi Arabia, we have a joint national plan for combating antimicrobial resistance in cooperation with health authorities, and we have a pioneering experience at the level of the Middle East to work according under the One Health approach. I would renew to the invitation to all stakeholders contribute to addressing antimicrobial resistance through spreading awareness and the optimal and responsible use of these antimicrobials and taking care of infection prevention measures, including vaccination in farms and veterinary facilities, and participate in raising awareness of the World Antimicrobials Week under the title Spreading Awareness, Stop Resistance. Finally, great thanks for our speakers, today Dr. Shabir and Dr. Mark, for valuable presentation. Also, many thanks to Elanco and all our respected
شكرا جزيلا.
شكرا جزيلا معالي الدكتور علي. بكرر شكري لحضرتك ولكل الإخوة في وزارة الزراعة، وإيلانكو دايما مستعدة للمشاركة في أي إيفنت أو أي توعية حضرتك تطلبها مننا. بكرر شكري لحضرتك ولجميع الحضور، وإلى أن نلتقي إن شاء الله في لقاء قريب بإذن الله. شكرا جزيلا.